Hi students, today we are going to discuss mathematical induction. Exercise 4.4, 7th problem. Using the mathematical induction, show that for any natural number n, 1 by 1 into 2 into 3 plus 1 by 2 into 3 into 4 and so on etc. plus 1 by n into n plus 1 into n plus 2 equal n into n plus 3 divided by 4 into n plus 1 into n plus 2. We have to prove by the mathematical induction. Given the statement, write in P of n. Let the statement, write in P of n equal to 1 by 1 into 2 into 3 plus 1 by 2 into 3 into 4 and so on etc. plus 1 by n into n plus 1 into n plus 2 equal n into n plus 3 by 4 into n plus 1 into n plus 2. Write the statement with P of n. First one, step 1 is put the value n equal to 1 given the statement. Write in here step 1. Put the value n equal to 1. Put the value n equal to 1. That is a P of 1. P of 1 equal to take LHS. LHS equal to take what of the value? First term. The first term is 1 by 1 into 2 into 3. That is a P of 1 equal to 1 by 1 into 2 into 3. That is equal to 1 by 6. That is equal to LHS. LHS is 1 by 6. This RHS, right hand side is, right hand side, RHS equal to n into n plus 3 by 4 into n plus 1 into n plus 2. Put the value n equal to 1, substitute in RHS. Put the value n values is 1 into 3 plus 1, 4. 3 plus 1, 4 by 4 into 1 are 4. Next one, put the value n equal to 1. 1 plus 1 is 2. 4 2s are 8. Next one, 2 plus 1, 3. That is 8. 8 3s are 24. Now cancel the value. 1 4s are 4. 6 4s are 24. RHS equal to 1 by 6. LHS equal to 1 by 6. The RHS equal to 1 by 6. Therefore, LHS equal to RHS. LHS equal to RHS. Therefore, P of 1 is true. P of 1 is true. The second one, step 2. Let us assume that P of k is true. Let us assume that P of k is true. Let us assume that P of k is true for n equal to k. Let us assume that P of k is true for n equal to k. Now substitute the value n equal to k in the given statement. Write in P of k equal to 1 by 1 into 2 into 3 plus 1 by 2 into 3 into 4 and so on etc. plus 1 by, put the value n equal to k. Write in k into k plus 1 into k plus 2 equal, put the value, n values is k into k plus 3 by 4 into k plus 1 into k plus 2. K plus 2, that is a P of k value. And next one, to prove that P of k plus 1 is true. To prove, step 3. Step 3. To prove P of k plus 1 is true. To prove P of k plus 1 is true, writing P of k plus 1 equal to k plus 1 equal to k plus 1 is, already P of k is 1 by 1 into 2 into 3. 1 by 1 into 2 into 3 plus 1 by 2 into 3 into 4 plus and so on etc. And so on etc. 1 by k, where k is k plus 1. The previous step is this one, k into k plus 1 into k plus 2 plus, put the value, k values is k plus 1. 1 by, where k is k plus 1 into K plus 1 is already K values is K plus 1, K plus 1 plus 1 is K plus 2, K plus 2 into K plus 2 is K plus 1. Here K values is K plus 1, K plus 1 plus 2 is K plus 3. K plus 3 equal to K into K plus 3. Here K values is K plus 1, K plus 1 into K plus 3. K value K plus 1, K plus 1 plus 3 is K plus 4 divided by 4 into, here K values is K plus 1, K plus 1 plus 1 is K plus 2. K plus 2, next one, K plus 2 is K plus 1, K value K plus 1 plus 2 is K plus 3. K plus 3. That is a P of K plus 1 equal to K plus 1 into K plus 4 divided by 4 into K plus 2 into K plus 3. Take LHS equal to RHS. To prove LHS equal to RHS, take LHS is 1 by 1 into 2 into 3 plus 1 by 2 into 3 into 4 and so on etc. plus 1 by K into K plus 1 into K plus 2 is writing P of K. That is, take LHS and this is left hand side. This one, consider this one is P of K. This is P of K plus 1 by K plus 1 into K plus 2 into K plus 3. You have to prove LHS equal to RHS. Take LHS is this one. Right, you consider P of K plus 1 by K plus 1, K plus 2 into K plus 3. Already P of K value, find out the value. K into K plus 3 by 4 into K plus 1 into K plus 2. Already P of K value, find out the result. K into K plus 3 by 4 into K plus 1 into K plus 2 plus 1 by K plus 1 into K plus 2 into K plus 3. That is equal. Take LCM. Take LCM. Take LCM 4 into K plus 1 into K plus 2 into K plus 3. Take LCM and cross multiply. That is the K times of K plus 3 into K plus 3. K plus 3 into K plus 3 is K plus 3 whole square. Plus this one is a 4 times of K plus 1, K plus 2 and K plus 3 plus 4. Take LCM. That is equal K into, now expand the K plus 3 whole square. K plus 3 whole square is A plus B whole square. A square plus B square plus 9 A square plus B square plus 2AB. Plus 2AB means 2AB, 2 3s are 6K. 6K plus 4 is divided by 4 into K plus 1, K plus 2 into K plus 3. Next multiply by K. Multiply by K. It is equal K into K square is K cube plus 9 into K, 9K plus 9K plus 6 into K is 6K square. 6K square. 6K square plus 4 divided by 4 into K plus 1, K plus 2 into K plus 3. That is equal K cube plus 6K square plus 9K plus 4. Now factorize K cube plus 6K square plus 9K plus 4. Using the prime factor. Now K cube 6K square 9 plus 9K plus 4. Now using the prime factor, write in a coefficient of K cube, K and a constant value. Write in K cube, the coefficient of K cube values is 1. Next one 6K square. Write in there 6. Next one, the coefficient of K is 9 and the constant values is 4 using prime factor. This one, K plus 1 is the one of the factor. Already K plus 1 is the one of the factor. Now check the results. K plus 1 equal to 0 to the value K equal to minus 1. Now check the value. That is a minus 1. Minus 1. Write in a 0. This place is 0. 1 plus 0 is 1. 1 into minus 1 is minus 1. 6 minus 1 is 5. 5 into minus 1 minus 5. 9 minus 4, add the value. 9 minus 4 equal to 4. Now multiply 4 into minus 1 is minus 4. The remainder value is 0. Remainder value 0. So get the factor k square plus 5k plus 4. Already one of the factor is k plus 1. K plus 1. K square plus 5k plus 4, that is a quadratic equation. Now factorize 1 4s are 4. 1 4s are 4. 1 4s are 4. Therefore the factors are k plus 1 into k plus 4. K plus 1 into k plus 4. Now k cube plus 6k square plus 9k plus 4, that is the factors are k plus 1 into k plus 1 into k plus 4. Write in k plus 1 into k plus 1 into k plus 4 is divided by 4 into k plus 1 into k plus 2 into k plus 3. Now cancel the value on k plus 1, k plus 1s are cancelled. The remaining result k plus 1 into k plus 4 is divided by 4 times of k plus 2 into k plus 3. That is RHS result k plus 1 into k plus 4 by 4 into k plus 2 into k plus 3. That is the RHS result. Is equal to RHS. So LHS equal to RHS. Therefore P of k plus 1 is true. Therefore P of k plus 1 is true. P of k plus 1 is true. The step 4 is by the principle of mathematical induction. By the principle of mathematical induction, P of n is true for all n. P of n is true for all n, where n belongs to n. Eighth problem. Using the mathematical induction, show that for any natural number n, 1 by 2 into 5 plus 1 by 5 into 8 plus 1 by 8 into 11 and so on etc. plus 1 by 3n minus 1 into 3n plus 2 equal n by 6n plus 4. To prove with the mathematical induction, given the statement, write in P of n. Now write in P of n equal to step 1. That is the statement P of n equal to, write the statement P of n equal to this one. P of n. Take LHS, put the value n equal to 1. Take LHS is, take the first term, put the value n equal to 1. That is the LHS is 1 by 2 into 5. This LHS is 1 by 2 into 5 is 1 by 10. That is the LHS equal to 1 by 10. And RHS is the right hand side. RHS is n by 6n plus 4. n by 6n plus 4. Put the value n equal to 1. Substitute the value 1 by 6 into 1, 6 plus 4 is 10. That is RHS. Right hand side is 1 by 10. So LHS equal to RHS. LHS equal to RHS. LHS equal to RHS. Therefore, P of 1 is true. P of 1 is true. And step 2, let us assume that P of k is true. P of k is true for n equal to k. Let us assume that P of k is true for n equal to k. Let the statement P of n equal to, given the statement, write in n equal to k. Now substitute the value n equal to k. Let the statement P of k equal to 1 by 2 into 5 plus 1 by 5 into 8 and so on etc. plus 1 by 3 n values is k, 3k minus 1 into 3k plus 2 equal n by k. The value n is k by 6k plus 4. 6k plus 4 is P of k. Next one, step 3. Step 3. Let us assume that P of k is true for n equal to k, step 2. And step 3 is to prove P of k plus 1 is true. To prove P of k plus 1 is true. Now substitute the value k is k plus 1. Now writing P of k plus 1 equal to 1 by 2 into 5 plus 1 by 5 into 8 and so on etc. Plus 1 by 3 into here k values is k plus 1. Now substitute the value k is k plus 1 and k is k plus 1. And the previous time is this one 1 by 3k minus 1 into 3k plus 2 plus 1 by 3 into here k is k plus 1. Substitute the value k is k plus 1 multiply by 3k plus 3 3k plus 3 3k plus 3 minus 1 is 3k plus 2 3k plus 2 into next one put the value k is k plus 1 k is k plus 1 the 3 into k plus 1 is 3k plus 3 3k plus 3 plus 2 is 3k plus 5 3k plus 5 okay put the value k is k plus 1 3k minus 3k plus 3 minus 1 is 3k plus 2 next one put the value k plus 1 multiply by 3 3k plus 3 plus 2 is 3k plus 5 equal to here k values is k plus 1 k plus 1 by 6 here k values is k plus 1 multiply by 6 6k plus 6 6k plus 6 plus 4 is 6k plus 10 6k plus 10 that is here P of k plus 1 to prove LHS equal to RHS to prove LHS equal to RHS take LHS equal to take LHS is this one 1 by 2 into 5 plus 1 by 5 into 8 and so on etc 1 by 3k minus 1 into 3k plus 2 is already consider that is a P of k that is the LHS equal to RHS LHS equal to now consider this term is P of k plus 1 by 3k plus 2 into 3k plus 5 we have to prove LHS equal to RHS RHS is k plus 1 by 6k plus 10 take LHS is P of k plus 1 by 3k plus 2 into 3k plus 5 already find out the result P of k values is k by 6k plus 4 plus 1 by 3k plus 2 into 3k plus 5 3k plus 5 is equal k by 6k plus 4 6k plus 4 taking 2 is common taking outside 2 into 3k plus 2 3k plus 2 plus 1 by 3k plus 2 into 3k plus 5 take LCM the cross multiply 2 times of 3k plus 2 into 3k plus 5 3k plus 5 multiply k into 3k plus 5 3k plus 5 plus 2 times of 3k plus 2 that is a 2 plus 2 that is equal multiply by k 3 into k 3k square plus 5k plus 2 is divided by 2 into 3k plus 2 into 3k plus 5 3k square plus 5k plus 2 is that is a quadratic equation. Now factorize 3k square plus 5k plus 2 3 2s are 6 3 2s are 6 3 2s are 6 add the value 2 3s are 6 add the 2 terms 2 plus 3 is 5 that is the factors are now the factor divide by 3 that is writing a factors are 3k plus 2 writing a factors 3k plus 2 into k plus 1 plus 1 by 2 into 3k plus 2 into 3k plus 5. Now cancel the value, 3k plus 2, 3k plus 2 cancel. The remaining, that is equal k plus 1, k plus 1 by k plus 1 by 2 times of 3k plus 5. Multiply by 2, 2 into 3k, 6k plus 5 2s are 10. K plus 1 by 6k plus 10, that is equal to RHS. So LHS equal to RHS. LHS equal to RHS, therefore P of k plus 1 is true. P of k plus 1 is true. Therefore, by the principle of mathematical induction, P of n is true. P of n is true for all n. The principle of mathematics, P of n is true for all n are natural numbers. So ninth problem, ninth one. Prove by mathematical induction that 1 factorial plus 2 into 2 factorial plus 3 into 3 factorial plus and so on etc. n into n factorial equal to n plus 1 factorial minus 1. Using mathematical induction, given the statement, write in P of n, step 1. Given the statement, write in P of n equal to 1 factorial plus 2 into 2 factorial and so on etc. n into n factorial equal to n plus 1 factorial minus 1. Now, to the value n equal to 1, take LHS. Take the left hand side is, take the first term, that is a 1 factorial. 1 factorial values is 1. 1 factorial equal to 1. And right hand side, RHS equal to n plus 1 factorial minus 1. Put the value n equal to 1. The value n equal to 1 is 1 plus 1. 1 plus 1 is 2 factorial. 1 plus 1 is 2 factorial minus 1. 2 factorial values is 1 into 2. 1 into 2s are 2. 2 minus 1 is 1. It is a right hand side value equal to 1. Left hand side values is 1. So therefore, LHS equal to RHS. LHS equal to RHS. Therefore, P of 1 is true. Therefore, P of 1 is true. And step 2, let us assume that P of k is true. Let us assume that P of k is true for n equal to k. Let us assume that P of k is true for n equal to k. N equal to k, substitute the statement, writing P of k equal, P of k is 1 factorial plus 2 into 2 factorial plus 3 into 3 factorial plus and so on etc. plus, here n is k. K into k factorial equal k plus 1 factorial minus 1. This is a P of k. The next one, P of k plus 1 is true. To prove P of k plus 1 is true. To prove P of k plus 1 is true, substitute the value where k is k plus 1. Write in the statement P of k plus 1 equal to 1 factorial into, plus 2 into 2 factorial plus 3 into 3 factorial plus etc. Here k is k plus 1. K plus 1 into k factorial is k plus 1 factorial. In the previous term is this one, the same, k into k factorial plus k is k plus 1 into k plus 1 factorial. K plus 1 factorial equal k plus 1 factorial minus 1 is already k values is k plus 1. K plus 1 is k plus 2. K plus 2 factorial minus 1. K plus 2 factorial minus 1 is, that is a P of k plus 1. We have to prove the LHS equal to RHS. LHS equal to RHS. Let us consider 1 factorial into 2 plus 2 into 2 factorial and so on etc. K into k factorial value is P of k. Let us consider this term is P of k plus k plus 1 into k plus 1 factorial. Take LHS to prove that RHS is k plus 2 factorial minus 1. To the left hand side, so consider the term P of k. P of k plus k plus 1 into k plus 1 factorial. K plus 1 factorial. P of k plus 1 into k plus 1 factorial. That is a P of k. P of k is k plus 1 factorial minus 1. Substitute the value. That is equal to P of k. P of k value is k plus 1 factorial minus 1 plus this is k plus 1 into k plus 1 factorial into k plus 1 factorial. K plus 1 factorial. That is equal k plus 1 factorial minus 1 plus k plus 1 into k plus 1 factorial. Now write in k plus 1 factorial plus, write the step, k plus 1 into k plus 1 factorial minus 1. Write the minus 1, the last step. Write in minus 1. K plus 1 factorial, k plus 1 factorial. That is a common value taken outside. K plus 1 factorial, k plus 1 factorial into k plus 1 factorial into remaining value 1 plus k plus 1. 1 plus k plus 1 minus 1. That is equal k plus 1 factorial into k plus 1 is k plus 2. K plus 2 minus 1. K plus 1 factorial into k plus 2 minus 1. Now write in k plus 1 factorial into k plus 2 is k plus 2 factorial. Write in k plus 2 factorial minus 1. K plus 1 factorial into k plus 2 is, for example, 6 factorial into 7. 6 factorial into 7 is 6 factorial means 1 into 2 into 3 and so on etc. 6 into 7 is writing is 7 factorial. 1, 2, 3, 4, 5, 6 and 1, 2, 3, 4, 5, 6, 7. That is writing here 7 factorial. So k plus 1 factorial into k plus 2 is k plus 2 factorial minus 1. That is a k plus 2 factorial minus 1 is RHS. That is equal to RHS. Therefore, LHS is equal to RHS. Therefore, P of k plus 1 is true. P of k plus 1 is true. And step 4, by the principle of mathematical induction, mathematical induction, P of n is true. P of n is true for all natural numbers. Now discuss example problem. Example 4.65. Prove that for any natural number n, a power n minus b power n is divisible by a minus b, where a is greater than b. Given a power n minus b power n is divisible by a minus b by proof mathematical induction. Given the statement, write in P of n. With the statement P of n equal to a power n minus b power n. A power n minus b power n is divisible by a minus b. Divisible by a minus b. Put the value n equal to 1. Put the value n equal to 1. Is a P of 1 equal to a power 1 is a. A power 1 is a minus b. A minus b. A minus b is divisible by is divisible by a minus b. A minus b also divisible by a minus b. Therefore, p of 1 is true. P of 1 is true. Next one, p of, let us assume that p of k is true for n equal to k. This is step 1. Step 2, let us assume that p of k is true for n equal to k. N equal to k. Write the statement p of k equal to, write the statement p of k equal to a power k minus b power k. A power k minus b power k is divisible by a minus b. A power k minus b power k is divisible by a minus b. Now write in a power k minus b power k is divisible by a minus b. A power k minus b power k is divided by a minus b equal to, write in some constant value. A power k minus b power k is divisible by a minus b divided by a minus b equal to some constant value. This implies a power k minus b power k equal to a minus b, that side multiply lambda of a minus b. Lambda of a minus b. This implies now find a power k equal to minus b power k, that side plus b power k. This is lambda of a minus b into, lambda of a minus b plus b power k. That is the a power k value equal to lambda of a minus b plus b power k. That is the equation number 1. Next, to prove p of k plus 1. Step 3. To prove p of k plus 1 is true. K plus 1 is true. Write in a statement p of k plus 1 is p of k plus 1 equal to, already p of k is a power k minus b power k. P of k plus 1 is a power k plus 1. A power k plus 1 minus b power k plus 1. A power k plus 1, b power k plus 1. Now write in a power k plus 1 is a power k into a power 1 into a power 1. Base are equal at the power k plus 1. Is there a power k plus 1, now split a power k into a power 1, write in a, minus b power k plus 1 is b power k into b. B power k into b is equal a power k, already find out the result, a power k value, substitute the value, lambda of a minus b plus b power k. Now substitute the value, a power k is lambda of a minus b plus b power k into a minus b power k into b from equation 1. A power k value substitute in this one. Now multiply by a, lambda into a, lambda a into a minus b plus a into b power k minus b into b power k, minus b into b power k is equal lambda into a of a minus b plus b power k is common, taking outside, b power k into a minus b into a minus b. That is equal a minus b are common, take outside, a minus b into lambda a plus b power k, lambda a plus b power k. A minus b into lambda a plus b power k is, writing lambda 2 or lambda 1. Is a minus b into lambda 1, where lambda 1 equal to lambda a plus b power k. So a minus b into lambda 1, a minus b into lambda, multiple of a minus b is, which is divisible by a minus b. The multiple of a minus b is also a divisible of a minus b, which is which is divisible by A minus B. So therefore P of K plus 1 is true. So P of K plus 1 is true, and therefore by the principle of mathematical induction, the principle of mathematical induction, P of n is true. P of n is true for all n. P of n is true for all n.